Hey there, this is Mr. Wilford, and I just wanted to go through Chapter 6, Section 5 with you. And in the last section, if you remember, we were talking about some special parallelograms, different properties and such. We were basically taking a look at rectangles, a rhombus, and a square. And in this section here, we're going to continue with that, conditions for special parallelograms. And what we want to be able to do is be able to prove that if we have a quadrilateral, that it is a rectangle, rhombus, or a square. And a couple of theorems that will help us get started here. 651 says that if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So this is kind of nice because we really just have to look at one angle, and if angle A here is a right angle, then the parallelogram must be a rectangle. In 652 it says if the diagonals of a parallelogram are congruent, then again the parallelogram is a rectangle. So now what we're doing is we're using the diagonals, we're measuring those, and we know that we have a rectangle. And this actually is used quite a bit in construction. If you want to try to lay out a couple of couple of 2x4s or something like that, if you want to figure out if something is rectangular, what you can do is actually measure the diagonals, and if they're congruent, if they're the same, you're going to end up with a rectangle, and that means that we're going to have 90 degrees. So here's an example here of a carpentry application, and as I mentioned, a lot of times you're going to be able to look at something that's supposed to be rectangular, and to make sure that, maybe what you would do is measure from point W to Y, and note that measurement, and then measure from X to Z, and if they are the same, if they're equal, then of course you're going to have a rectangle. This is going to be a rectangle, and the angles here will be at 90 degrees. So that's kind of a helpful little theorem, something to keep in mind. And then a few more theorems. This has to do with a rhombus. 653, if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So we're looking at these consecutive sides. If they are congruent, or the same length, then we are going to have a rhombus. If the diagonals of a parallelogram are perpendicular, then we're going to have a rhombus as well. So if you could measure these, if you can take a look at the diagonals and you can measure this angle, if that's 90 degrees, you will have a rhombus. 655, if one diagonal of a parallelogram bisects a pair of the opposite angles, then the parallelogram is a rhombus. So again, taking a look at a diagonal, if that diagonal cuts this angle F or H in half, then we are going to have a rhombus. Here is a proof that you can take a look at and read through. Here's an example that kind of goes through the idea of a rhombus and some of the diagonals and it being perpendicular. And then here's another example here, and this is more of kind of a grid for us to take a look at, and you can actually use the distance formula to make some measurements, AC and BD, and so on, to determine what exactly we're looking at. The example continues here, and then there's an example B as well. So make sure that you take the time to look through that. Example B here, we're looking to determine if it's a rectangle or not. So again, check those out, and if you have any questions, let me know. Hopefully they're a little bit more concrete because we're so used to dealing with rectangles and rhombuses and squares and things like that. But again, if you have any questions, please let me know. Thanks.